Welcome back, Math Nines. This is going to be the beginning of our next unit on Chapter 4, focusing on linear relations. We're going to get into graphing. In our first lesson here, 4.1, we're just going to be learning how to write some equations to describe some pretty simple patterns. So in this first lesson here, over yonder, we have figure 1, 2, and 3, and you can just imagine this on your desk or your table as toothpicks being laid out in the shape of squares. And so we can record the number of toothpicks in each figure in something called a table of values. We're going to use these a lot. Table of values. And we're going to look for patterns now. So here's our table down here already created for us. Notice the titles here. We have figure number. We're calling that F. And we have the total number of toothpicks. We're going to call that T. So in our first figure here, we can simply count how many toothpicks we have. There is one here, one here, one here, one here, giving us 4 toothpicks. If we look at the next one, we can see those 4 are still there, but we've added an additional 3 toothpicks, making it 7 in total. And in figure 3, again, these are all in figure 2, and our new ones are 3 more again, so we start to see a pattern. We don't need to continue to draw these figures. We can see right away our pattern is that the number of toothpicks every time you add a square increases by 3 toothpicks. So the next one for figure 4 would be 13 and then 16. Okay, now let's describe the pattern in the table above as simple as possible. So we want to say as, and we always look at our what's happening on the left here first. Left to right is how we work. As the figure number increases, and it's increasing by 1, so increases by, we'll say +1 to make that really clear. The number of toothpicks increases by +3. Okay, and so we can take that and we can graph what's happening here. Now, this is going to be a bit of a review right now, but the left column is always the same as our X, and the right column is always the same as our Y when we graph in the general case. When we're graphing in the general case, X is always a cross. Okay, X looks like a cross, so this is our X axis, this is our Y, but we're given some context here. So we're actually going to label these axes properly. We have figure number F. So this is the figure number, and it's denoted by the letter F. And then over here, it's going to be tricky to write sideways on here, but we have the number of toothpicks. So we're going to write this as number of toothpicks. And that's denoted by T. Apologies, that's a little hard to read, but this is not easy to do on a writing pad. Okay, and so figure number, as we plot these are like coordinates. So you can think of this as, if we were to put brackets and a comma, you should have seen this before. So at 1, 4, so figure number 1, it's 4 toothpicks. So we can draw a coordinate here. Figure 2 is 7, figure 3 is 10, figure 4 is 13, and we go off the graph here, but it would be just up above for figure 5 would be 16. Okay, and so we can see these patterns a little more clearly by showing it in another way. Kind of some rough work would look like so. As this side is increasing by 1, so every time we're increasing by 1, increasing by 1, increasing by 1, this is consistent, it is constant. And over here, we're increasing by +3 each time. +3, +3, and finally another +3. So we have consistent change or constant change on both sides. And a longer way of writing that is we can see a steady increase to the figure number is +1, produces a steady change in the number of toothpicks, +3. Then the points, as we saw on the graph, they do fall on a straight line. And so this is our first example of a linear relation. They fall on a straight line. Figure numbers are related to total toothpicks. And now we're going to try and create an equation, which is a little bit tricky. Now, the strategy here is we always start with whatever variables, our variable for on the right side here, which is t. I want to write it in terms of um, the total toothpicks in terms of the figure number. So what does that look like? Well, the total toothpicks is going to be t, and that's equal to some equation using f. So I'm going to leave a little space here, some equation with f. So we got to look at our pattern here. And this plus 3 that keeps happening with every plus 1, we call that a multiplier. Multiplier. And that multiplier multiplies with the figure number f. So it's going up by 3. So we could add 3 over and over and over again, or just multiply it by 3 would suffice. Now, there's a problem though. If I put in, say, 2, if I input a 2, I don't get a 7. Because if I put a 2 in for f, 2 times 3 is 6, I don't get 7. So what we do as a quick strategy is to see what are we missing. We have to go back one. So we go back one here and we go back to the 0 figure. So we subtract 1. So we're at the 0 figure. And if I'm going back one, I'm going to subtract 3. So the 0 figure would have a total of 1 toothpick initially. So we have to add that on. That's what it started with. And then we're adding 3 per figure number. So that's what we set up here. Here's our first equation. So if we input, we can test this. We can test by if we say, hey, what if f equals 3? So if I put in f equals 3, let's see. So 3 times 3, I put in a 3 for f plus 1. We do our BEDMAS, that's 9 plus 1, which equals 10. So we can say t equals 10, and that matches our table right here. When we put in a 3, we got a 10. So that's a great test to make sure your equation works. Moving on. Now that we have an equation, if the pattern continued, how many toothpicks would be in the 24th figure? Now, do not draw 24 pictures. We're going to use our equation. So what this is saying is the question says how many toothpicks. So it's saying t equals what, or question mark. And this is saying that for a given f equal to 24. This is figure number 24. So we can take our equation where we had t is equal to 3f plus 1, and then we're going to substitute f equals 24. So that becomes t equals 3. I'm just going to emphasize how we substitute again. Whenever you substitute, always use brackets. Okay. And so we're going to put in 24 right here. And now we can do good old-fashioned BEDMAS here. So 3 times 24 is going to give me 72 plus 1, which is equal to 73. So T is our 73 toothpicks. So using our equation, we were able to quickly determine the number of toothpicks without drawing 24 pictures. Now we can go in reverse. What if we know the total toothpicks? So this is telling us T is equal to 100, but it wants to know the figure numbers. So this time we're trying to find what is F. So let's just use our equation one more time. Let's do it over here this time. We have t is equal to 3f plus 1. And now we know t is 100. So we're going to substitute 100 in for t and now solve for f. Now we learned how to do this in our last unit. We're going to put up our fence. Okay. And we're going to solve for f. So we're going to subtract 1 on both sides. That's going to give us a new equation of 99 is equal to 3f. And now we're going to divide both sides by 3, which is going to give us our final answer of 33 is equal to f, as the 3's have canceled, the 1's have canceled. And so this is our figure number. Okay, example 3. Let's look at a different type of context here. We have distance related to home from driving. We can see this looks like if this is the distance from home, we're decreasing this time. So someone's on their way home. We can see our pattern is going up plus 1 again. Over here on the other side, though, this time it is negative. We are decreasing by 3 kilometers each time. Okay, and it wants us to find that equation again. So remember that this is our multiplier. Okay, and we always want everything to equal the right side variable, which is the total distance. D is a function of time. So we need an equation using t. And this looks like the multiplier this time is -3. So -3 kilometers per minute of time is what's happening here. But again, we have to figure out what was it at the 0 minute. -1, we get the 0 minute. And go this time the opposite is +3. We're going to be at 14 kilometers. So our 0 minute's going to be 14. Again, do a quick test. Okay, let's put in 2 this time. So D is equal to -3 times 2 plus 14. Let's see what we get. And D, we're being told at 2 is supposed to be 8. So let's just check if this is true. We get -6 plus 14. And yeah, looks like -6 plus 14 equals 8. So check, check. Both sides equal each other. So we know our equation is correct. Finally, let's take a look at this pizza example. It is an expensive pizza. So we're told the base cost, you just get, the pizza with tomato sauce and cheese is $13.95, and then they charge an additional $1.50 for per topping. So to get an equation, again, we just take a look at our patterns here. This is going up +1, +1. Over here, we're increasing by $1.50 each time, $1.50 plus another $1.50. And so again, we have our multiplier right here, multiplier. And we're going to set up always a right variable. The total cost in this case is equal to some function of the total toppings. So we're going to be putting, sorry, that should be a T. I almost wrote an F. T. And then in front of that, we're going to be writing our multiplier, right? So that's $1.50 times T. But then we need to get our 0. But we're already told this. I can subtract $1.50, but we're told in the question that this is $13.95. Okay, if we go back to what if we've had 0 extra toppings? It was just tomato sauce and cheese. So we have to add on the base price. So now this equation should make sense. The total cost of the pizza is $1.50 per topping plus the base price of $13.95. Now, pizza cost $30.45. So this is our C. C equals $30.45. And it wants to know how many toppings. In other words, T equals what? So let's set this up. We use our equation up above. So I'm going to say 30.45 is equal to $1.50 times the number of toppings T plus $13.95. So we're going to once again use our stuff from our last linear equation unit where we are solving for unknowns. We're going to first subtract 13.95 from both sides. Okay, that's gone. That's going to leave me with, on the right, I'll just be left with $1.50 times the number of toppings. And then on the left, I'll be left with $16.50. And now finally, we just need to divide both sides by $1.50 to solve for T. And this pizza's got a lot of toppings. We'll end up actually reducing this. Whoops, I did it again. T is equal to, and when you divide that by $1.50, you get 11 toppings. Let me fix that. That looks nothing like a T right now. And we'll be done this lesson. 11 toppings. Okay, so review. What do we do in this lesson, grade nines? Basically, we started looking at patterns in different ways. We had a picture format, we had different tables, we had this setup of distance as well as a pizza. So different variables being related to each other in a linear way allowed us to create these equations. When we create these equations, we always make the left side equal to the right side variable, which is T, the total of whatever it is, total money, total toothpicks, total distance, whatever it was on the left. And then we make it equal to some function, some equation using the multiplier from the pattern, multiplies with the first variable, usually figure number or time in minutes, or we saw that with pizza toppings. It could be anything. And then we had to add on the zero term. Okay, so that's where each of these pieces came from. And I hope this helps moving forward, and good luck with the practice.